Hello, everyone, and welcome to SQL Friday. This is SQL Friday number 6, and our star of today is Mike Byrd, who's going to present a self-tuning fill factor technique for SQL Server. The session is being recorded, and it will come online on YouTube and embedded on SQLFriday.net if you click on past sessions on the website. I'm really happy to have Mike presenting. Right now it's 5 a.m. in Texas, where Mike is. So I really appreciate you, Mike, standing up in the middle of the night to present to us. We talked about it before. You said it's better than having someone call and say the database is slow in the middle of the night. But still, I really appreciate you doing this for us. So I'll let you do your own introduction of who you are and hand over to you. Welcome, Mike.
Okay, do you see my...
Do I see your screen? It's coming. I see, yeah, now I see your screen. Yeah.
PowerPoint slide?
Yeah, Mike Byrd, ByrdNest Consulting.
Okay.
Yeah.
Okay, good. For most of y'all, it's probably good afternoon. However, for me, it's good morning, and I'm going to leave it that way just because it is very early here. I've had my one cup of coffee, so let's get started here. This is a topic I'm very passionate about. And who am I? I literally wanted to be an astronaut, so initially I was a rocket scientist, then I joined the Air Force, and I actually lived in Germany 4.5 years in the early 80s. I was a tech writer for PC Magazine. I was a CTO for an insurance company, and actually after 9 years got a new boss, and he and I parted ways. And so I moped around for a couple of months, and one of my consulting companies that I hired me, and then that got me back on the technical side, and I just love being a database geek. I blogged a lot on logicalread.com and also recently on SQLServerCentral.com. In fact, I had a blog published last week on SQLServerCentral.com. But I just like digging into the optimizer black box, and literally I'm just a geek. There's all my contact information. You don't need to write it down because these slides and everything will be available via GitHub, and they're available right now, actually. I speak Texan. I hope y'all understand me. Here's a map of the United States. If you look at Texas, there's a triangle formed by San Antonio, Dallas, and Houston. Austin is just northeast of San Antonio, and then I live roughly 75 minutes away from Austin to the northwest. And if you look at the little picture there, in about an hour, that's what it'll look like out my kitchen window. I live on a lake, and it's a great place to live. Although right now, for the next week, we're supposed to have temperatures Fahrenheit over 100. So maybe not so great for the next week. Okay, I've had my coffee. The doc said I probably should only have one cup of coffee a day, and so that's my coffee cup right there.
I have a request in the chat. Someone asks, Damir asks if you can minimize the little Teams window because it's covering the presentation.
Yeah.
Perfect. Okay. Thank you.
I didn't realize I was going out. Okay, the presentation slides are available at GitHub under mbyrdtx, and then, as he said, we will have the link to the video shortly on SQLFriday.net. Again, I think you get most out of this presentation if you just listen, and then later on you can review the slides and script later, and if you have any questions, just email me. That's the easiest way to get hold of me. Today we're going to talk about fill factor. What is it? How is it used? An approach I took to try to figure out how we can actually determine what a good fill factor might be. A very short review of the code. I hate reviews of code, but I think it's necessary so you can sort of see the approach I took. Some analysis of the results I initially got, conclusion, observations, no demos because this takes too long. I could not present it in a 60-minute period if I was doing demos. I will show you some screenshots though. I did an early version of the presentation and code was at SQLCentral.com as shown there, two-parter. And then there's an early video from the Austin Users Group at that web link there. But the latest code and the presentation is available at GitHub and Dropbox. But GitHub is where I want you to go. Don't worry about Dropbox. If you've attended any of my presentations in Index, you've probably seen this slide, and the slide is that how everybody typically presents how indexes are organized through a B tree, and actually everybody presents it kind of wrong, because in reality everything's linked to the left. I mean, you fill up pages as you go through, each one of those boxes being a page, and you can see that you start with the root page, which is the root level, which is your highest level, and then you may or may not have intermediate levels, and then you have your data for the index down in the leaf levels. And at the intermediate and root levels, all you have really are pointers pointing down to where the actual each row is. So what is fill factor? Fill factor is defined by Microsoft as percent of fullness of leaf level pages of an index. So as you put in rows in an index, and it doesn't matter whether it's clustered or non-clustered, you add a row and it's going to keep going into a page until the page is full. Well, then what happens when the page is full and you want to add another row? Usually it'll go to another page, and we're going to talk about good ways it does that and bad ways it does that. So let's talk about good page splits. Say you have a table that has a identity column as your primary key and also your clustered index. And so when you add a row, it's just added at the end of the table. And that's called a good page. And so when the page gets full, it goes to the next page. Next page being next page in the extent of that, of the current extent. And if that extent is full, there are no more pages left, then it goes to a new page in another extent. Okay, so the consecutive, and usually as you add rows, only the last page is not full in the extent or in the index. We also have bad page splits. Whoops. I did another blog on that, and showed numbers in that, and average bad page split, which I'll explain in a little bit, took almost no time CPU-wise, 0.035 milliseconds, but it had a significant number of logical IOs, and we'll talk about that in a little bit other. And when you have bad page splits, you get both internal and external fragmentation. And we'll talk about that some more too. The trick is when you're trying to determine the fill factors, find a value that minimizes your bad page splits but doesn't result in an excessive storage penalty. And that is an issue I'm still trying to work on. So for the last 4+ years, I've really been looking at indexes, and if you've heard any of my presentations or seen them, you know that I love working on indexes and how they affect performance. But I've really never understood how to determine the good fill factor for an index. I mean, there's some guidance out there, but there's no definite path. There's just no definite guidance. So what to do? So let's talk about a story. In a time wrong story. A couple of years ago at a speaker dinner for SQL Saturday, several of the other presenters asked me if I'm so good with indexes, why don't I do a presentation on fill factor? And I thought about that, and I'm going, well, how would I even approach that? And then at the next SQL Saturday, the next year in Colorado Springs, I attended 2 sessions by Jeff Moden entitled Black Arts Index Maintenance and so forth. They were actually outstanding sessions, and they can be downloaded at the link you see there. But essentially what Jeff talked about was that the popular concept we now have to reorganize at 10% and rebuild at indexes at 30% was probably not the way you really need to do it. He showed in the 2 presentations that page splits cause tremendous performance degradations, and you should probably rebuild indexes at 1% fragmentation. I pretty much go along with that, but again, his whole concept of what he was doing and the way he showed it and the performance degradations got me to thinking. And so on the flight back home to Texas, I got to thinking about everything he said and how fill factor also factors into index performance and maintenance. And fill factor is obviously what you get when you defrag your indexes. It also got me to thinking back a long time ago when I worked at the Air Force Rocket Propulsion Laboratory, that there was a brute force optimization technique that I had used in some instances there back in the old Fortran days. And yes, I once was a rocket scientist and still a geek. It was a technique that involved tweaking various parameters, plus and minus percentages, and trying to reduce those plus and minus percentages down to finding an optimum performance number. It was not always perfect in a multidimensional scenario because there are values the solution could drill down on, but it did offer near optimum solutions, so let me explore options. And so that's a technique that got me to thinking, well, how do I do this? So what was my approach? My approach was to take a technique similar to Hola's defrag script and modify accordingly. And I'd been using a version of his script already for defragging indexes and running once a week. His script reorganizes at 10% and rebuilds at 30%. I was already using this script, but because of issues with Azure, I wasn't doing any reorganizing, and the reason being for cost. And then I was using the rebuilds at 10%. And so to use the technique I was talking about, this brute force technique, I needed to be able to track what was going on. What was the actual fragmentation versus the fill factor for each index? And then I need to vary fill factor to be able to see, well, how did it affect the fragmentation value? So I needed a table to collect the information, to collect the parametrics involved with the whole index rebuild process. And so this has started a table, and I don't expect you to go through and do it. You're going to get a script that generates this table anyway. But I was collecting, the table name, the index name, partition number, what the current fragmentation was, how many. Initially, I was not capturing bad page splits, and we'll talk about that in a second, and so forth. And I captured this information, and for the first month, I just looked to see what kind of data was I capturing with those values. And every night I ran and got the top 20 indexes with the worst fragmentation and or bad page splits. The number 20 works best for the database I was using. We'll talk about its size in a next slide, or slides following. And you can change 20 to something else. And then some from Ola's script, you have sys.dmdb index physical stats, where you can get the average fragmentation. You also have sys.dmdb index operational stats, which gives you leaf allocation and non-leaf allocation. Those latter numbers didn't. And then after about a month of tracking data, I found an article by Jonathan Kias from SQL Skills on how to actually capture bad page splits. And there's a link to his article. And then I also have documented within the script itself. So now with his information, I can now capture not only what the current fragmentation was, but how many bad page splits I'd had over a period of time. So let's dive a little bit more into fragmentation. You have logical fragmentation, and that really is where you have the pages of an index that are in extents. Remember, there are 8 pages per extent. When you either create an index or rebuild it, the initial page comes from a mixed extent. Excuse me. The allergies here in Texas are still driving me up the wall. I do not have the virus, by the way. Anyway, so when you get a new rebuild index, the first page comes out of a mixed extent, and mix being there's something else also being used pages within that extent. So we have 2 types of fragmentation. We have internal and external. Internal is where you have too much free space. In other words, you have actual space within an index that's not being used. External fragmentation is the pages are out of order, but usually when you have a bad page split, you also free up and have internal fragmentation too. So internal fragmentation is what we get, and that's the number you see when you run the DMV that I talked about earlier. A page that is 100% full has no internal fragmentation. It usually occurs when you have deletes or where the next row can't fit into an existing page, which is a bad page split. By not filling up a page, you're going to increase your I/O, because now you have, for a given number of rows, more pages for each, or more pages for the lesser number of rows in each page. And because of that, then you have a problem with your buffer cache and increase the size of database factor. And you'll always have some internal fragmentation when you rebuild an index with a fill factor less than 100. Great article, and the link I show there on internal fragmentation. External fragmentation occurs when the logical order of the pages doesn't match the physical order of the pages. In other words, there's something out of order. And usually what it means is that the out of order page is in another extent. So now SQL Server has to go find where the other extent is and pull that off the hard drive or out of buffer cache. So let's look at it and see what I'm talking about here when I said all this. Okay, so this is just a partial view of a B tree before adding a row. And you can see down at the bottom at the leaf level, all 3 pages are absolutely full. So if we had like a clustered index built on a identity column and we added a row, what happens is that if there's another page in the existing extent, then the page will just be added and you get the linkage that's shown there. Not only do you get the linkage between pages, but you also have the linkage from the root level and intermediate level down. Sometimes, though, when you add the new row, it'll actually cause a split up in the intermediate level, which is another page split, and you can see it still occurs, but you still have all the linkage from page to page. Now, suppose we have a case where we're going to add a row, say, in the second page that you see at the bottom of the screen there, and that page is full, so it won't fit. So what happens is, and the article I just published in SQLServerCentral.com, I actually show numbers and how this, from looking at DBCC page, is that the page where you're going to add the row is full, then it creates a new page, which is not necessarily in the same extent. And now you have pointers going down to the new page, and that new page probably is in a different extent. And also, half the rows in the old page are pushed down to the new page, and the new row that you added is in the new page. So that's not only a lot of I/O, but it's also everything is logged in transaction log. And if you remember from a number I showed you earlier in another blog I did, that for the example I was running, it averaged about 6 extra page I/Os per bad page split. Let's look now and see, and I guess I better minimize that. Well, that's not what I wanted. Come on, Alt-Tab. There. Okay, so I have 2 scripts. One's a setup script, fill factor index set, as you can see at the top here. And all it does is create this, what I call the history table. It creates a schema called admin, because I just wanted it something different than what the rest of the database was in. And here's that same table I showed you earlier being created. The reason it's in dynamic SQL is because if you create a table, it likes to be the first statement in the batch, and I didn't have it. I'm creating the schema first. So, and then also in the setup script, I create the extended event that Jonathan KS had mentioned. Again, there's the link to it. That creates the extended event that tracks the bad page splits. And I start the session, obviously. And then lastly, I created another table, and I'm still looking at this table. It's not being used for calculating fill factor now. I'm just watching it to determine what kind of history I'm getting for bad page splits per day. Let's go over to the script that actually does its work, all the work. And there's lots of documentation and lots of variables. And I apologize right now for the script. I keep modifying, adding to it. It has not changed since I originally did the proof of concept. And excuse me, and this proof of concept was actually a proof of concept, and I didn't intend for it to go into production, but it went into production just the moment I developed it, like all proof of concepts tend to do. But anyway, I just want to go through it, not to show you what the actual code is, but just sort of what's going on within the code. Here's the key for tracking what's going on. Okay, every day, this isn't a SQL Agent Job, every night in this particular production server, which is a very active OLTP server running 24 hours a day, but the low ebb in the process usually is between 7 and 10 p.m. at night, local time here in Austin. I take the top in this case 20, and into a temp table called work to do. And that gives me up to 20, and I have where conditions down here at the bottom that, where the index ID is greater than 0. So I don't want to collect heaps. It's a user table, and the average percentage is greater than 0, and then the frag is either greater than 1.2, and the split count is the bad page splits are greater than 50. And I'm only looking at the root level for 0. And then I have my OR clause, order by clause. I either order by either the fragmentation or the bad page splits divided by the page count. Then because of some inputs I've gotten in the past, I have a lot of, you'll see this in the code, if the show process is equal to 1, then I do a lot of debugging here. And I'm still playing with this script, and I still modified it as late as yesterday. That one table I talked about earlier that was in the setup script, bad page splits, again, it's nothing to do with the actual fill factor yet, but it's just collecting data for me to watch. Okay, so what do I do? Okay, so now that I've collected the up to 20 worst fragmentations or bad page splits, and I've gotten the bad page splits, I stop the extended event, then I restart it again. And that way I'm collecting bad page splits over a 24-hour period. And then after I'd watched the data for a long time, I said, well, what happens when the data changes the way it's being used? What happens if you start getting new data SKUs? What happens when you add new stored procedures and indexes and new tables and or the data within it changes? And so I finally figured out that I needed to go back and every now and then look to see, well, what is to reevaluate the fill factor for something that's more, in this case, the redo period is 90 days. So I tend to add one row. I look back, see, is there anything older than 90 days that hasn't been touched that has a bad fragmentation? And so I have logic to go in and add one more row back to work to do. And I update various things and I insert it into work to do again. It's just one row and one column, and it seems to work really well. All right, anybody awake out there? Because I'm almost put myself to sleep. Okay, so now I set up a cursor.
I'm still awake.
Now I set up a cursor to go through each index that I've captured and work to do and evaluate and see if I need to play with it or not, or tweak it or not. And there's the show process. And so here's my cursor, fetch next, and I set up a bunch of things. And then I gave this presentation at SQL Saturday Baton Rouge 11 months ago. And I got some inputs back because we were still talking, I was still working on logic to how do I set the fill factor? And so I got a lot of feedback, and they said, well, as a minimum, you need to look at the last 6 tweaks that you've done on it to see what's going on. And if you can find a minimum value within those last 6 tweaks, maybe that's how you determine what the new or what the fill factor should be for that particular index. And so this logic here, 6 entries, goes back and looks at the last 6 entries that are sitting there in the history table. And then I had to add logic because even though this particular database doesn't have any partitioned tables, and you'll see this in my wish list further down, one thing Microsoft has never done is allowed us to have different fill factors for each partition. And ideally in an ideal world, you'd like to have all your old partitions have a fill factor of 100 because you're not really modifying that data, and all your new partitions where you have active data going on, you'd probably have like some number less. But anyway, I don't want to change fill factor for partition tables, and so I actually check to see if this particular index is partitioned or not. And if so, I just defrag it. I don't adjust the fill factor at all. Okay, you see this number here, or parameter workday. After watching the data for a while, I realized that, well, gosh, the workload Monday through Friday is heavy, whereas the workload on weekends is light. So up above, I do have logic to check to see if it's Monday through Friday. If it is, it's a workday 1, and if it's not, it's workday. And so when workday is 0, I just defrag. I don't do any tweaking of the fill factors. And then the logic below is to set, and you can see I'm looking at index ID greater than 1 means it's a non-clustered, index equal to 1, it's a clustered index. And so I have logic to go through and check to see, well, how do I do it? I also, within that logic, I check lag date. Well, when was the last time this particular index had been touched, and it resides in the history table? And so if it's less than 14 days, like you can see here, I adjust the fill factor, subtract 2. If it's greater than 14 days, that means it's not as active a table. I adjust it by 1. It's just a good number or not. I don't know. This approach I took, and it seems to work for me. And I never let the fill factor get less than 70. So then I set up, if the index is not partitioned, I set up the dynamic SQL to do the rebuild with the new fill factor. And if it's 1, I just rebuild it, but don't defrag it really. And if it's a workday is equal to 0, which is in my case Saturday or Sunday, then I set it to just rebuild again in a defrag, and I execute it. And you see within this part, there's the command that does the actual execution. But I found out I was starting to get deadlocks because even though the database is not very active between 8 and 9 o'clock p.m., I was still getting some deadlocks. So I have a logic here where I do a retry. And I do up to 6 retries if I have it. If it doesn't, then it doesn't rebuild it, and doesn't enter into the history table either. And then once I rebuild, and I go back and get new numbers to see, well, what's the new fragmentation and so forth, and I insert all the data I need to collect. In fact, I collect too much data, and that's one of the things I need to do when I do my code cleanup is go back and not collect all the data that I'm collecting right now, and I insert it in the history table. And that essentially is the script. And then I have some data retention ideas down here. Okay, so that's the script, and let's go back and look at what's going on. Okay, so as I said earlier, this is a SQL Agent Job. You can see there the script that I just showed you is sitting there on the lower right-hand side of your screen, and it is under my defragmentation, because it does both. It both defrags and it also tweaks fill factors. And you can see it runs daily, and it runs at 8:20 p.m. local time here in Austin, Texas. So what did I do? Okay, so initially I set up a SQL Agent Job to collect data and vary fill factor from 100 down. And I run it during low database activity. And I do use, if you looked real close at some of the code, or when I generated the rebuild script, I do use the online option, which is only available in Enterprise. As the data collected, as I collected data, I added new columns to the history table and revised the logic to determine NR fixed fill factor. Initially, I just manually fixed it for a couple of tables, but then I finally came across a means, as I showed you earlier in the code, where I could dynamically fix it when it found a ebb or a low point in the fragmentation versus fill factor. And then as I said earlier, I have a need to retweak the fill factors after a period, and that can be set to something other than 90 to allow for new patterns and so forth. Here's an example I ran right before the 4th of July, and you can see on June 30th there, the bottom part of that data that it collected went through. There's 7 indexes that got tweaked on July 1st. There's 1, and then on July. So that's where I am now. Pretty much the system is stabilized and it's collecting data, and I use a breakpoint of 1.2 for my fragmentation and 50 for bad page splits. If I look recently, though, on July 5th, I went back and added a new clustered index for the table file, and that changed all its non-clustered indexes for that. And so you can see files showing up a bunch here, and so you can see a variety of data. It's not up to 20 yet, but a variety of data with the bad page splits. You can see I still, like for this particular here, IDX file underscore priority outpour template del flag, I had over 10,000 bad page splits, which is probably going to start affecting performance a little bit. Oops. And then down at the bottom on the third, you can see before I added that index, I only had 5 records that were collected. Okay, so is anybody awake out there still? So I ran data collection on a very active client OLTP database. This is a client I've had for 16 years, part-time. I initially came in as a T-SQL developer, part-time, and they have made me their accidental DBA, which that seems to happen a lot. The database a year ago was 225 gigabytes of real data that didn't include the Sprox views or anything else, or 249 tables, or 694 indexes, and it runs 24/7. First 90 days I ran, only 164 indexers, clustered and non-clustered, were recorded in the history table, and the fill factor tweaked. It's a few more now, but not a lot more. So what kind of indexes did we see? Well, we had on the cluster indexes, we had ones based on the sequential increase, like the identity column, and then we had ones that were based on the parent table plus some primary key. Like for file attribute table, we had the primary key was file ID, comma file attribute ID, where file attribute ID was identity column. And then we had our normal non-clustered indexes, which are usually based on some non-primary key. So let's look at some examples. And I don't mean for you to look at the numbers so much. I just want you to know the numbers here because they're reflected right here in the graphics. And so what I was looking for, and this is that first 90 days when I went active, I was manually just looking at the numbers to see, well, what was going on? And so frequently, for a lot of cases, I saw a case where initially at 100%, and this is one on the based on the identity column, at 100%, and start tweaking it down, that eventually goes down to some low level and then bottoms out. And so in this particular case, it bottomed out at a fill factor of 88%. And here's again, don't worry about the numbers so much, just looking at the next slide. This was an interesting one to me. It started at 100%. Very first time I tweaked it down to 99%, it went to a low value, but then it jumped back up 98, 97, and I finally figured out that, well, that 99 was probably on a weekend. And then you can see it stabilized down around 96%, and then it started to stabilize there, and that's what I tend to look for. And what I'm trying to do by looking at this data is trying to figure out, well, when do I set the fill factor? And usually once it starts to level out, I'll start looking for a minimum value, and that's what I'm going to use for my fill factor. Again, don't worry about the numbers. And you can see this pretty much shows exactly what I was talking about. This is a non-clustered index. And again, it usually, almost all the cases, it always started off with a high value for fragmentation and then drop down to a low value. And you can see that those are not going down very much below 1. And this was an interesting one that was a non-clustered index where at 85 is a relatively high value of fragmentation, and then at 83, 81, and 79, it came out to be identical the same. So obviously, in this particular case, you'd always want to pick 83 for a fill factor. But this got me to think, well, how do I fix it, and how do I fix it? So I look at the last 6 data sets for each index. If I don't have 6 data sets, I don't fix it. I find the smallest fragmentation in that 6 sets. And if it's not the last one, then I set it to the fragmentation I set the fill factor to where the fragmentation is the smallest. If the 6th one is the smallest, then I don't set the fill factor. I continue to perturb the fill factor and see what happens on the next run. Identify the fill factor for the smallest fragmentation, and then there was in the history table, I have a column called fixed fill factor. That's easy for me to say at 5 in the morning. And that pretty well then says don't tweak this anymore again, at least for 90 days. The script then checks the fixed fill factor and stops tweaking when it's not null. I did all this, and like I said, it was a proof of concept. We went immediately into production. And this is a screenshot from SolarWinds DPA. I like DPA. It's my own personal choice, just mainly because it ties query plans to wait types. And average performance during the day for this particular database was averaging between 350 and 500 seconds over a 10-minute period. This screenshot was shot before I started the fixed fill factor. 90 days later, late June of 2019, you can see now it's averaging between 250 and 350. And I'm going, wow, what a significant drop. And each one of those color blocks there is a specific query plan tied to a stored procedure. In this particular database, we only access data through stored procedures. There are no ad hoc queries. So this really led me to think, well, maybe this is really good, because now I see wait times reduced of about 30%. And I know the two shots were at different times, but they were very typical and indicative of performance throughout the day. With these decreased fragmentation, there are less page splits to wade through for IO range searches. And with improved fill factor, there were just less bad page splits. And you see that also, and I don't have a graph showing that, and now that I think about it, maybe I should. The cost of a page split can be significant. You have to identify the new page, pointers moved to do it, and you got to move all the data, and then it's all that is logged. So what do you need to run this? Well, you need 2012 and above just to get the extended event for the bad page splits. I recommend the enterprise version because that's the online option. Standard edition can be used, but you have to be wary of schema locks. Data compression, I recommend row for every table, even if they're small tables. It costs you almost nothing in CPU time, and it saves you a lot in buffer cache. I already have it in Enterprise, and then in 2016, Service Pack 2 and above for Standard Edition. Okay, this is my wish list. What do I want to happen going forward? Well, I have partial code in there for multiple databases on the same server, but I don't have that implemented right now. Right now, it's for one database on one server. So the new code coming forward, if somebody out there wants to do that, here's a project you could have, but now you may want to have a separate database just for the history table. I still haven't come up with a perfect parameter for determining best performance for fill factor versus the page use. That's something else I'm still working on. I've been watching it for a year, and I still haven't, the light bulb hasn't gone off for me yet. It needs to be rewritten. I was looking at it again this morning before I came on, and I'm going, gosh, I wish I cleaned this up before I distributed it out to the general public, but it does work. As I said earlier, I wish that Microsoft would get off their duffs and allow separate fill factors for each partition within a partition database. Many of my clients like to partition data, not necessarily for performance, but for data retention, and it would really be nice if the old partitions could have 100% fill factor, the newer ones something less than that. Try and build in additional features as suggested by the community. More testing on performance improvements. I really would like somebody to put it on their production database and just see how it works over a period of time. I need a better way of monitoring, especially the history table. Right now, I just do it manually and with self-review. I'm looking for some volunteer out there to implement some kind of dashboard to sort of give you an idea of what's going on with the history table over a period of time. One of my things on the wish list was to get in the GitHub. I did that this spring, and it's there, and it's under MByrdTX. And some way to compare index growth to see, well, as your tables grow, you may need to go back and readjust fill factor, and that allows for that 90-day redo period that I had before. And I guess right now, in my mind, I'm still trying to decide, should I base fill factor on fragmentation or just on bad page splits? And I haven't come to a good decision because I see pros and cons on each side of the fence there. And as I said, I'm still monitoring and analyzing, and I'm going faster than I thought. Hey, we're doing it. So what are we talked about? Well, it started off as a proof of concept. On this particular production database, 30% improvement in wait times is significant. And since I've done that, I have not had a phone call from the client, especially that 2 a.m. dreaded phone call, since I've implemented this. Well, I take that back. I had one phone call, but it was because we had a failover on the always on, and that had nothing to do with the database. It had something to do with the hardware. Big idea is that, hey, I found a way that we can effectively determine automatically determine what fill factor can be set to. I'm not sure anybody has done that. I mean, we've alluded to it. Jonathan Hess in his bad page split article talked about it, but he didn't automate it. Now, the automatic part is what I've done, I think. I've been in production for 15 months, and this code both defrags and determines fill factor. So, again, I talked about that already. The only slowness complaint I get from that particular client now is when they implement new stored procedures without telling me. Remember, I'm an accidental DBA, and so if they don't tell me, I don't get to review it. And developers don't always write the best stored procedures. Sorry, I said that. It's just true. That's what keeps me. True. That actually keeps me in business. I don't mind it at all, because without them, I wouldn't be in business. I've copyrighted this here in the United States with the idea that it belongs to the SQL Server community. I didn't want some third-party person to take off with this, although they're welcome to, just don't charge for it. And I really look forward to constructive critique and suggestions for improvements from the SQL Server community. And with that, any questions out there? And I don't see that dashboard for the questions. I've lost it.
Sorry, you don't see what?
I don't see the question or comment tab.
Oh, okay. I have the chat open, and I don't see questions in the chat. But I do hear a strange echo with the sound, but that's just life with Teams, I guess. Now it's gone. I have one question though, which is, have you seen any difference in the time it takes to run this maintenance compared to when you just did the Ola Hallengren index defrag scripts?
Well, when I did the defrag scripts, remember, I originally, before I started all this, I was doing it 10%, and the times have been, actually with this now, because of the narrowing down, once the fill factors have kind of been determined already, the times have gone down significantly. As you saw in my two screenshots, in one case, I was looking at only one index at that night. In another case, I was looking at 4 indexes and so forth. So just the actual rebuild times have dropped tremendously because of the fact I'm looking at fewer indexes.
So I think that's also, I mean, if you get any improvement in wait statistics and you can get down your maintenance windows from, I mean, usually that's a problem with big databases, that you only have so many hours during office hours, and then so if that can be improved, that's a huge thing for many organizations, I think.
And again, you know, and Jeff Moden's articles, he really talked about, 1%. I used 1.2% because I could, in this particular database, I just couldn't, it was too many if we went below that. But 1.2%, by rebuilding, and then you go longer times before the fragmentation builds back up to a value that requires it to be really re-looked at or defragged again. So, yeah. And that's kind of what Jeff talked about in his article. If you go to a low value of fragmentation, you go a longer period of time before you need a rebuild. So have I measured that from your question? No, I haven't measured that, but I've observed it just by watching the data that yes, I'm not, my usually at night, this job takes anywhere from 10 to 40 minutes. And 40 minutes is like where I added that new index that I showed y'all on July 5th. And 40 minutes is quite significantly lower than what it was running before.
Yeah. I was doing some, there's a Swedish MVP named Tibor Karasi he wrote a blog post about the fragmentation, and he was measuring if fragmentation really cares in terms of performance when you do index scans and so on because most modern storage is SSD nowadays, which is more random access. So if initially came up with numbers showing that actually it doesn't affect performance that much at all. But then he made a follow-up, and when it comes to memory consumption, fragmentation is still very painful. So I mean, we want to keep fragmentation away, but maybe not for the obvious reason of I/O being faster if it's not fragmented. But it still affects the memory usage a lot if you have lots of fragmentation. So.
Yeah, it's still, even with SSDs, I have another presentation on in-memory tables, and I had a lot of interaction with Bob Ward on that particular presentation. And for in-memory tables, scans take just as long as a hard drive because it was just not designed that way. I mean, and range scans especially, or range seeks even, took a long time. They're running faster. So I would suspect with SSDs you have the same issue there. But you're absolutely right. With SSDs, because of the cost of them, you'd like to minimize how much storage you use, and so the more you're fragmented, the more you're going to have to. And it also takes up buffer cache too.
Yeah, and I did some testing myself, and I tried to keep the fill factor to the same level with, I mean, both when they were fragmented and non-fragmented to not skew the comparison. But of course, I mean, in a real life scenario, you want to keep the fill factor, I mean, as high as possible, but still not painfully high to cause plate splits. So.
Right.
Cool. I don't see any more questions. So we still have.
I really would like for other people to look at this and give me feedback on is it working for them? Will it work for them? And any suggested improvements would be appreciated.
Yeah. And I mean, since the code is on GitHub, I guess people could make contributions both with requests and maybe, I don't know, if the repository is made in a way so you can contribute code to it as well and branch out and so on. But I think it's an excellent start. So it would be really nice if this could be further developed, and I would like to use it.
Well, I mean, anybody who's going to turn down a 30%. Now, that was for the particular database I used. It may not be the same number, or it may be better, it may be worse for somebody else's production database. On a data warehouse, I'm kind of curious about that because of the flow of data in and out of a data warehouse. I don't know how it would work there, but I'd really like to see. I don't have access right now to a production data warehouse where it's actively being used, almost all day. But I really would love to see, could it help there or not?
Yeah, and I mean, for me, one really big thing is to try to minimize the time for the maintenance windows. Even if performance is okay as it is right now, still the maintenance windows data tends to grow and grow and grow and grow. So maintenance takes longer and longer. So
yes.
And anything, I mean, if I don't need to rebuild an index, I shouldn't. And if I can keep it from having to be rebuilt as long as possible, that's a really big win.
I agree. One thing I forgot to mention is that when you add data to a database or to a table, it doesn't use fill factor. It fills it right up to 100%. It's only when you do the rebuilds that you get the fill factor comes back into effect. And yeah. I say that, and that's true 99.9% of the times. But my friend Jeff Moden has found a case where it actually will fill to the fill factor. But 99.9% of the times, it's going to fill up the page completely.
Oh, okay. It's funny you mentioned Jeff because I'm in discussion with him and we're discussing dates, and it looks like he will be sometime end of September. He will be on SQL Friday as well. He just needs to figure out a topic that he can fit into a 60-minute format. He tends to want to have a longer time for it. But, it's going to be an interesting one.
Oh, I'll make sure I'll watch that too. I love watching him, and you're right. His data is so I want to use the word complete. I mean, he gives the full picture, and I enjoy listening to him, but he has a hard time fitting it into the 60-minute window.
Yeah. Well, to be honest, I do as well. I always have to skip something in the end because it doesn't matter how much I practice my presentations. When I come to do them, there are people asking questions, and I want to elaborate on the questions. And especially if it's a demo-packed presentation, then I'll just have to skip the last third of it most of the times.
Yeah, I have another presentation, Climbing the Bee Tree, where I go through and show how all the words of mouth that we have, all the thoughts that we've heard about that we never have seen verified on indexes, like unique indexes perform better, and it's a fun presentation for me to give. But you're right, you start getting questions, and some of the questions will take you off a path that sometimes make it longer than you want it to be.
Yeah. Anyway, I don't see any more questions in the chat, so I just want to thank you for coming to SQL Friday, Mike. I really enjoyed it. I'm going to explore your scripts a lot, and hopefully I can make some contributions as well if I find something, especially the multiple database part of it. I think it would be interesting to try and tweak too.
Okay. Thank you much, and I appreciate everybody attending. I hope you got something out of it.
I did. I just took over the presentation, so I hope you see my screen now.
Yes.
Perfect. So thank you, Mike, for coming to SQL Friday. The upcoming SQL Fridays, you see them on screen. We have a quite packed schedule. I had 2 open dates until just a couple of days ago, but they were filled with Alex Yates and Guy Glancer. So now we have until September 18th. We have really interesting upcoming sessions. Next week is going to be Ben Weisman, who just came out with his Pluralsight course on big data clusters, and he came out with the second edition of his book on big data clusters. So that's going to be an interesting one. And just go to SQLfriday.net, check out the schedule.